Hello to everyone. Thanks for your time and consideration. This is the agenda that we have prepared for you today. It's basically 5 points. A brief introduction on SN integrity of sensor networks, then talk about non-intrusive ultrasonics for corrosion monitoring, then discuss a couple of local case studies before handing over to my colleague Steve Strachan from Sensor Network. And then we're going to close this section with a QA where all your inquiries will be discussed and hopefully answered by us. So SN integrity, established in 2017 with the aim to become the preferred provider of state-of-the-art ultrasonic. Since then, we have secured leads with industrial leaders, companies worldwide like Sensor Networks, which is based in State College, Pennsylvania, founded in 2014, and is a technology company focusing on asset integrity solutions. Has so far developed 6 patents and got 75 employees, and some of the majors worldwide are already their customers. 3 main lines of business: custom-made and standard transducers, remote high-definition visual inspection cameras, and non-intrusive UT corrosion monitoring, which is our focus today. For more than 100 years, internal thickness inspection has been based on human activities, early by shutting down equipment and doing close visual inspection, later by doing manual ultrasonic, therefore, were time-based inspection instead of predicting-based. That continues to be the case today with integrity programs based on periodic inspection versus ongoing monitoring. But this mentality should be abandoned, as manual UT monitoring is by nature sporadic, prone to errors, potentially unsafe, and we know we've now got superior systems that can overcome these limitations. So the following example is a real case on a refinery where some of our sensors were deployed for continuous monitoring, a piping system, and at the same time, a tech was sent to the same location for monitoring every 2 months. This graph showed the data that he collected over that year or so, with a range of variability around 2 millimeters. And we know a definite trend that can guide the integrity team and the process guys. When we add to this the continuous monitoring data, we can straight away see that during that period were 2 particular events where a high corrosion rate was developed, and we feed back that information to the process engineer so they could understand what was going on and do the corresponding fixes. That would be missed out, only manual we would have at the time. So this is the beauty of having this kind of system. Our sensors can be divided in wired, where frequent measurements are required, but wireless infrastructure is not available. It is noted, although data is collected manually, it still offers the advantage to set data collection from easy to access point. Then wireless, where there is no need to access sensor after commissioning, as data will be sent by communicating to a gateway by, for instance, a long-range Radio 1 network, or by using the existing public mobile network for auto data transfer to an internet cloud-based analytics software. Wired or wireless sensor can be installed permanent or temporarily, giving the engineer the chance to decide as a case-by-case what the best option. So, non-intrusive based sensor for corrosion monitoring. Sensor network got three main platforms: single point monitoring or micropins, multi-point monitoring of smart pins, and area monitoring that can be by using a map with up to 32 sensors, and it can be square or linear. So talking in more details about micropins, three main components for this platform: web pin-based array for trending monitoring, exporting and reporting data, a gateway to communicate with the sensors, and sensors that can be stored from 1 to 1,000 to the same gateway. So talking in more details, can be stored permanent or temporarily, limited to above ground location, suitable to -40 to 500 degrees C, fully wireless with data on premises or cloud-based. Used then for when high accuracy near real-time data is required, or as a proxy to control integrity operational windows, example, change of inhibitor, crew slay, process excursion, covering many discrete points with simple attachment. You can start from 1 to 1,000. The limit is really your CapEx budget. The figure on this slide shows a trial done with a micropin at the back of a ute traveling around a very convoluted US refinery, where we managed to get up to 2 kilometers of maximum communication distance between the micropin and the gateway. On the left, you see some details of the micropin system. It is a 900 megahertz star network that is communication only between the sensor and the gateway, not between sensors, saving in batteries, which is an advantage from our competitors. Gateway capacity of more than 5,000 sensors with just one gateway, with data band hold to cellular, Wi-Fi, or hardwired from gateway to the cloud. And a major advantage, about 10 years on one reading per day of the battery of each micropin. So talking now of the smart pin, again, can be stored permanent or temporary, either above ground or buried, with temperature range similarly to the micropins, -40 to 500 degrees. And depending on local availability, can be wired to operate data control system, act as a data logger, or a standalone deployment with data going straight to cloud using public mobile network. Data can be also kept on premises or to cloud-based software. Used then when a large number of sensors in close proximity are required, example on elbows, vessels with different nozzles, etc. And for fitness for service calculation, where quick estimate of corrosion rate on low spot is required, as they are quick and easy to deploy within hours after the kit is on site. Now the max pins, again, installed above or below ground. Temperature range though is -40 to 65 degrees C, and data is on demand only. Then can be kept on premises or loaded into cloud-based software for analytics like corrosion rates and light, etc. Used then for large area monitoring after patch welding, box fix repair, or when directly assessing of non-trouble spot like impingements, corrosion erosion on elbows or teeth section is required. It's kind of install and forget system because it doesn't got any moving parts of battery or anything. So it only get wake up when the check comes over and plug into the connector to read it. So for the installation of micropin, it's really simple. The tech, we use a tablet to calibrate and tweak ultrasonic setting like the ID location, reading intervals, data transfer intervals, and also amplitude of the signal, etc. Those sort of things that you can always calibrate with using UT. It takes an average between 10 to 30 minutes per sensor. And again, the maximum life is about 10 years if we set it off at one reading per day. Some example of high temperature deployment. You can see the footprint is very small with just a quarter of inch hole. Through the cladding, you can install it and seal it properly. It won't be an water ingress point like the normal manual inspection point become easily over time. It can also be clamped on and then put the new flexible jacket that are now commonplace, be pulled over, and you are in business monitoring that hot spot. And for low temperature, we go a magnetic base. We can easily be installed and move it around as you please. Some example of high temperature deployment where you can clamp the sensor and permanently store. And on the right, you go a multiple deployment on an area more heavily affected that you need to monitor. So you can see, you can play around with the sensor and put it in the correct location to target the lowest point on a particular spot area. So another example of the versatility is this particular case. This is up 25 meters in this platform. We install the controllers units for the sensors. Then the sensor up also about 30 meters in the air. Only at the time of installation, you need some kind of access, like a raw access or a platform being built. But after it's done, you remove it and you don't need this extra cost going forward. And you can bring then that reading, instead of going up 25 meters to ground level, with a technician will plug it in onto the system and read all the sensors up 30 meters high or so. This is another example. This was a vessel that got a fitness for service calculation. That fitness for service said they cannot go on the 0.07 inches. So they were sending someone twice a day to read the area, and he was coming back with different readings every day, not making sense, some kind bigger, some kind lower. So they decided to temporarily install our sensor. You see the control unit attached to this scaffolding post there. And the sensor spread out onto the lowest point, having to read the thickness every 4 hours with data going straight to the cloud-based software for corrosion rates calculations. So problem solved for these guys. Now I'm gonna show a couple of local cases here in Australia. This is an unpickable new branch that was going across existing corridor with 4 major lines. So the new branch is a U-shaped, going down 5 meters deep. So they were looking at a system to monitor for internal corrosion from above ground. Then we come along and propose to them to install some mat pins at the bottom of the U coming from the first elbow, one linear at the top and one square at the bottom, and bring that above ground where they will be read by a technician quarterly or whatever frequency at the end the operator wants to use. So this is the sensor being glued to the new branch on the workshop where it was being welded together. This is how it was wrapped up with viscoelastic coating after the top and the bottom were installed. And this is after they was down to the trench and commissioning. This is the box above ground on the CP post where the techs will plug in the tablet or a laptop and get the readings out of it. So the benefits are very cost-effective ultra thickness monitoring, ultrasonic thickness monitoring that will last over the pipeline span. Another interesting case, this is a CO2 absorber on a DLNG plant. It's a new vessel and it was shut down for the first year internal cross-visual inspection as per standard requirement. And the integrity team was shocked, found hitting localized corrosion between 1 and 3 millimeters. So they need quickly to work it out whether this was a one-off excursion or was something that was going on. So they mapped out the lowest areas and they contacted us with the following requirements: a system for a carbon steel vessel, very thick, nominal wall thickness was 110 millimeters, operating at temperature range between 70 to 90 degrees C. So we propose to use 2 SmartPin cellulars with 8 dual element probes, temporally magnetically attached with 4 reading per day and transfer data once a week, with the DSI bolted to an existing light post nearby in the tower. And this is how, after the sensor went room to each lower point, and has been installed since December 2019 with no issues whatsoever. So again, they save by avoiding scaffolding and repeat inspections, because they got access to data 24/7, and also the ability to cross-check impact of process excursion almost in real time. And they can then add and avoid this kind of corrosion that cause high corrosion rate on that particular vessel. So the data collected by these systems will use what we call the web pin, where we do all the analytics, trending, and reporting. It can be graphical like this one, but can also be tabular. We're gonna see that in the demonstration that my colleagues will be doing, follow this. So I just quickly show you this slide only, you get the picture, and you're gonna see this live very soon. So that can be hosted on an Amazon Web Service, or can be also kept on premises using your intranet and located on site. So this closes my part. I thank all of you. So I now will hand it to my colleague.
Okay, great. Thank you, Nestor. Very, very well done. Thanks to everybody for joining. Nestor did a great job kind of giving the overview of the different corrosion monitoring hardware and software that we use for really a whole myriad of different applications, whether upstream oil and gas, midstream pipelines, above ground, buried compressor stations, things of the like, as well as process stations, refineries, chemical plants, and things like that. So part of the process that, get some people in the waiting room, I'll let in really quick. Part of the process of the to show you guys today is really give you a feel for some of the products and do a little visual kind of hands-on. So I'll start with smart PIMs, and as you can see, I have a pipe sample over here that we do kind of little demos and things. But this is the transmitter that Nestor was talking about. It's kind of looks like a flow meter housing, and it's about 5 pounds. So you mount this on handrail, bolt it to whatever have you, and then the cellular version, there's an antenna. If there's no antenna, there's a Modbus cable that comes out of here. On the other side is actual cables, and some folks prefer them to be armored cables and other folks unarmored, but at the end of the day, you have the actual sensor part, which is can be a dual element transducer, and the sensor actually looks like this. The sensor's in the middle, and it actually is spring loaded. It's about a 3/8 inch sensor with a magnet on the outside. So when I actually find my spot to place the transmitter, I then can either use epoxy to adhere the sensor to the pipe, or I can use a temporary kind of putty or couplant we call, this is called Stopac. This is good up to about 65 degrees C. And then, if it goes over 65 degrees, sometimes you have to replace it. Otherwise, you can epoxy them in. But it's really as simple as just putting a BB of this on here. And if you can see my screen, you find a spot, and you literally put the sensor down, and away it goes. So it's really pretty straightforward, pretty quickly. If you want to relocate them or move them around and you're using the different types of couplant, you can. And with it being in cellular, as a cellular device, anywhere that I have cellular connectivity, where it can wake up and send a signal, whether you can send a text or send an email or make a phone call, these will wake up and do their thing, and then send the data to the cloud-based backend. So that's smart PIMs. The second product is called Map PIMs, and this is for the buried line that Nestor was showing before. Really what it is an area monitoring strip. This is a 3x5, so there's 15 active elements, looking at about a 1/2 inch, so 12 millimeter by 12 meter area between each individual sensor. And it's epoxied on permanently. And on the other side, there's a cable with a connector. So if this is buried underground, this would be coming up to a collection post. And you could plug in periodically, get your data, and then you could put it out to the cloud or put it off to an Excel spreadsheet, things like that. So we use these a lot for buried applications for midstream oil and gas or mining, or other types of slurry or erosional style failure mechanisms. So that's Map PIMs. And then the last one is the newest product that we started working on about 2 years ago. They're called micro PIMs. And so what these are fully wireless sensors. As you can see, this is a high temp sensor. It is about 18 inches tall and weighs about 1.5 to 2 pounds. And they have these bases on them. And you can see the sensor at the bottom here, which you put a piece of metal foil, and then you use this strapping mechanism. So this is a 3-inch strap that we use. They all look similar to this, but you need a different strap for each individual, whether it's a 3-inch, 4-inch, what have you. So you put the strap on first, and then you insert the probe later, and you use a piece of metal foil. You use these little bolts here and here to tighten it down until you get an ultrasonic signal. At which point, you know you're good to go, and you can go to your next sensor. Here's a picture of the dual element sensor and the magnetic base, as Nestor showed you before. So again, instead of those little brackets, you have these magnetic clamps. These are good for vessels and tanks and things that are lower temperature in nature, but they're really kind of similar to the dual element smart PIMs, and that you take them, find your spot, and they're done. So it's pretty straightforward, pretty easy. You can move them around. You can also use epoxy if you like. A lot of folks, don't like to, want to be able to have the flexibility to reuse them. A lot of folks do. So in which case we use the snowpack and things. I'm not sure if you can see up at the top, I got a picture of a high temp sensor that has been banded on. So you get a feel for what that might look like. Okay. That's my hands-on part of the hardware, the comments, and I can answer some of the questions. I can take it from the top. Let's see. Okay. So the first question is, how long will Sensor Networks take to get approval for the wireless sensors to be installed in Australia? So good question. We've been working with Nestor and the team for about the last 3 or 4 years now. He's put in quite a few smart PIMs and map PIMs. Really the only holdup right now is for micro PIMs. We're in the process of getting our ATEX certification, which is in process as we speak. And we're working on the wireless back end to be able to work in the 900 megahertz frequency in Australia. And so we're really looking at probably about 8 more weeks, so between now and the end of the year, to have all the certification and all the efforts in place from a paperwork perspective to be able to hit the ground running. But what we told Nestor is, work with customers and find out, if they have some areas that are good candidates to start to try to get some of the micro PIMs out, and we can certainly accommodate you and do what we can, to help your time frame. With that said, the Smart PIMS product is Class 1 Div 2 ATEX Zone 2, so that product is already ready to go. We're just putting the final touches on micro PIMs, because every country in the world has different, every country in every region, I should say, has different wireless protocols, and you need to be able to, transmit legally in different parts of the world. So we're really, really close, and probably between now and the end of the year, for certain, we'll be able to start getting some deployments in Australia. Next question was from Ray, and he says, what were the expected corrosion mechanisms for the unpiggable line case? Nestor, you may be able to speak to that a little bit better than I can.
I mute.
Yeah, I can hear you, Nestor.
You can hear me?
Yeah, we can hear you.
Okay. Yeah, well, there was, as a precaution, because the line wasn't possible to inspect it, so they have to come up with a way to have some indication of anything happening on the lines. So, because the being U-shape installed at the bottom of the U was the lowest point, so that was they would expect if something would occur, would it be there. And doing this during project is very cheap to do it, and give them peace of mind that they were doing the right thing. At least they were getting some indication of what's going on the bottom of that pipe. There was not a particular corrosion mechanism, but there is always the potential to develop, especially on lower points, and that was the reason.
Okay, great. And then the next question was, what are the mining applications? we've been doing a number of mining applications, a lot of times for erosion or slurry lines, where there's high wear, whether it's in the feed piping that goes into the process unit, or whether it's in the actual process unit, because there's a lot of very highly erosional processes that are happening at different temperatures. And so it's, like I said, it's kind of similar to a refinery, only it's more erosional because of the harsh product flowing through the pipe. So whether it's matte PIMs or smart PIMs, those are two really good products for it, just because a lot of those slurry lines are very close to the ground. And a lot of times they want to look at the 6 o'clock position of that slurry line. We do a lot of these in Canada as well, in the oil sands, where they actually physically rotate the pipe when the 6 o'clock, it's usually between about 4 and 8 o'clock that the pipe gets worn, and then they'll actually go out and they'll turn, 90 degrees and, look at the new 6 o'clock. So that's a typical erosion kind of mining application. Got a couple of notes that said they couldn't see my screen, so I'm not sure.
If you want, I can share a web ping with my screen, so make it more clear.
Go for it, yeah.
I will do that now.
Okay. And while you're doing that, Nestor, I'll just keep answering some of these other questions.
Yeah, but you need to hand it back the hosting to me so I can share the screen, or get you are sharing your screen at the moment, so get off and I probably can share mine.
Okay. There you go, you're now the host. Can you hear me, Nestor?
Yes.
Okay, cool. So okay. Real quick, I'll keep going through some of these chats very quickly. Is there anything to monitor external corrosion from sensor networks? No, unfortunately, our sensors are ultrasonic based, so they're only looking at the ID of the pipe. So the ultrasound is very good for looking at a volumetric inspection, but the near field obviously is at the OD of the pipe. So, a lot of those applications are like corrosion under insulation and things like that. Unfortunately, ultrasonic sensors really aren't built for OD style corrosion. The next question was, what is the max area that can be monitored? Are suitable undersea applications? The max area that can be monitored by a matte PIM, as I said before, is kind of like a 2x3 area, and you're looking at a point every 12 millimeters. So that's the kind of spacing you're looking at. Each one of the sensors themselves look directly underneath where the sensor is placed. So in the case of a dual element sensor, it's actually a roof angle sensor that looks at about a 1/16 of an inch of area. So it's a very, very, very small area that the sensor is actually looking at. So, if you move the sensor a millimeter up, down, side, or side, you'll likely get a different answer or a different thickness, just because it's very, very precise. For the high temp sensors, you're looking at about 1/8 of an inch of area, which again is a small area. But, what I always tell a lot of folks is, the good thing about installed sensors is they're looking at the same spot over and over and over and over again, which allows you to get that very precise reading. The bad thing about them is they're only looking at one spot over and over and over again. So if you're not in an active area, you're not in a good spot, and something's corroding or eroding, an inch or a foot or, a couple of feet away, you're not going to see it. So these are sensors that are used for monitoring purposes, not so much inspection. It's about finding the location or the areas that are a bad actor spot and putting the sensors there and understanding how to tweak those parameters to be able to do that. The other question was, is it good for subsea? In theory, yes, you could. installing them could be a little bit of a challenge, and you probably could only get, you know, maybe a couple 100 feet down. But I would say yes, but with some caveats. So we probably need to talk a little bit more in particular about those applications in detail. Another question. Go ahead, Nestor.
Let me talk a little bit of the wet pins, because on the graph there was difficult to see all the details. This is what you got on the screen there. Is a real case of a wet pin deployment on a trial for a customer. So they already got a low point that they know they have to replace. So they ask us nevertheless to monitoring for a while. And you can see it was 3 millimeters over time on the graph there, you can see. And then they replaced it, but they did not tell me about it. And the guys that did the replacement put the sensor back on the same point, as you can see. On the 28th of April, they change the pipe, and then you start see nominal thickness of that pipe, 7.5. So this is the kind of thing that you can get. Some of the features you can, by hovering over the graph, you can have the corrosion rates that you have been measuring day by day. And you can add also by right click on a particular section, the system will calculate for you the rate that happened during that particular period, and based on that rate, what is your end of life for the system. So as I say, you can have normal graph result, but you can also have tabular data, and you can download it as a CSV file and play with it. You can also filter or get data that doesn't make sense for you out of that. And with the web pin also, you can interrogate your system to see how it's working, like the battery status, the signal strength. This is a mobile unit, and if it's an error, this is reporting error because it's no longer installed. We removed it. And temperature is reporting error also because we never put a thermocouple to read the temperature. But that unit, the hardware itself, is in good condition. So all of that is for each data is stamped, and this is info that you can access for auditing purpose. You can also allow to add photograph. So if someone is becoming responsible for this facility today and some of the reading go to an alarm, you can quickly jump in, open photograph, and see what that particular sensor is installed. And you can then direct your NDT tech to site to have a look and check what is happening in that particular location. So this is the versatile of this system offered to you. So there you go. That's where the TML is installed. So we get out of that where no, the information is in a hard drive somewhere. The tech is no longer with us, so maybe on this folder, have a look. I said, no, you got all that information already available for you. Even if you start today, you will be capable to direct the team. This is the station where the thing is installed. This is the sensor that is in fail. So go and have a look and scan the whole spool. I need you to bring me that report as soon as you can. So this is kind of thing that you're gonna have handy, available for you.
Hey, Nether, pass me the host back really quick. I think I know what I was doing there before, but I have a really good example of WebPIMs on my screen. So I can share that with the team here and then continue to answer the file. So here's, again, like I say before, a picture of WebPIMs. You can take a reading here, and then you can cut it, take a reading here, and then you can do more down here, right? You can also click material temperature if you want. So each one of these sensors actually has a thermocouple for surface temperature built in. Here you go. So this green line is actually the temperature. So you can see 17 degrees Celsius. And then what you were actually seeing is when they would increase the temperature, the corrosion rate would go off the charts, right? And then they would decrease the temperature and the corrosion rate would stay the same, and increase the temperature and it would start corroding again. So just an example of, being able to look at some of these different things. If I take off the temperature and I get rid of some of these boxes, you can actually also put in there a temperature adjusted thickness reading, which is actually this one, but then all I can do, this is just the raw data. So it's pretty similar because it's not super, super hot, but you can do a lot of different things, and then you can do, different short-term corrosion rates or what have you. So, so there's a lot of different things you can do with the tools in WebPIM. So that's what I wanted to show you guys. With that said, we'll see if we can answer a couple more of these questions before the end. So let me see where we're at in temperatures here, or where we're at with questions. Okay, so question was, what are the other products likely to be launched by Sensor Networks in the future, which can benefit the oil and gas and mining industry? We're going to continue to build out on the 3 platforms that we have. We're really focused on micro-PIMs right now. For obviously the reasons you saw that Nestor said before, the super long range capability. It's very economical, very affordable, good battery life. The wireless infrastructure to have, you really only need a couple of gateways to have full coverage of a location. And it doesn't cost, some of the other wireless technology that's out there, like Wireless Heart or A100, can be very, very expensive. So there's a lot of, actually the reason we went with a 900 megahertz product was at the recommendation of our customers who are already using 2.4 gigahertz and Wireless Heart and ISA 100. They said it's just too expensive and we need something that's a little bit more economical, that we can start putting thousands and thousands of sensors out there. So that's really where we're focused right now. But obviously we have a couple other things in the pipeline, which we'll be able to talk a little bit more about when they get to be closer to launchable. What is the min-max thickness capabilities on the high temperature sensor? You can see from 0.1 inches up to 1 inch in thickness, and to 500C. And on the dual element sensor, you can go from 0.04 inches up to 4 inches in thickness. So that's the 2 ranges, and those sensors are the same for smart PIMs and micro PIMs. Can these be installed at locations where the pipe has a dent, damage external, to monitor the future internal corrosion? Maybe. The sensor has to sit flat, whether it's, or it's, relatively flat surface. So if you can get the sensor to sit on it and give you a good reading, then yes. But if it's too dented and you can't get the sensor to sit flat on the area you're looking to measure, then likely not. Asset owners are moving into the digital transformation and have or plan to have their own digital platform for data storage and analysis. How flexible is your system to adopt and adapt to digital platforms and to provide only segmented parts of your system, like, for example, only the sensors with the digital communicator? How adaptable is your system for this scenarios? Great question here. So we are using 900 megahertz LoRaWAN technology. So our sensors have 900 megahertz LoRaWAN modules in them, which means that anybody that's putting together their own 900 megahertz LoRa private network can use our sensors or anybody's sensors that have LoRaWAN modules in them. So in a lot of cases, there's a lot of major oil and gas companies that are building out their own 900 megahertz LoRaWAN systems and calling us and saying, hey, we just want to buy your sensors and we're going to integrate them ourselves into our system so they can manage and maintain and monitor the data. So that is a very real scenario that a lot of people are doing, and we've been very successful with a number of majors who are looking to do that. Just because, as I said before, a lot of these majors are seeing the significant advantage of 900 megahertz LoRaWAN, which is why they're building out that infrastructure in a private network. Yeah, for more information, we can certainly talk about it, but that's a very, very real thing. So suffice to say, our stuff's pretty flexible. Whether you want to, buy gateways and servers and all that fun stuff from us, or just the software, or sorry, just the sensors, you can do that too. Another question is there any gland design improvement because it was rejected by our team in one gas plant? Yeah, so there are different connectors you can put on there that are, that sometimes are more HAZLOC friendly in certain situations. It's really a case by case based on what people want or can't have. But yes, I can send some pictures of some examples of different hazardous rated glands that we've used in some cases. Another question is, how can we comply with confidentiality of the measured results while data are going to be stored on the cloud-based platform, which is not under control of a client? Another good question. I would have told you 5 years ago that, everybody was saying, cloud-based data being held is never going to happen in our lifetime. But, folks like Chevron and some of these other guys. But about 2 years later, they came to me and said, this is the way the world is going. Everybody's going with cloud-based data wherever humanly possible. Folks like Amazon Web Services and Microsoft Azure, the two big cloud providers, are probably putting as much money into cloud-based encryptions and security as probably the Department of Defense is. So, I think a lot of asset owners really in the last 2, 3, 4 years have looked at this data and said, how critical is thickness data? Is it 401ks, social security numbers and things like that? Or is it just thickness data that sits off of the system and just monitors? It's not in the process control loop. It's not super confidential data. Can we do it? So a lot of people really have started migrating to the cloud. But then there are also people that don't want to have either those private networks that I was talking about, or have their own, have us, provide them beyond the system. Very good questions there, and we can talk about that for a while, but that's kind of how I would answer that at a high level. Is there any way of taking all readings together in one graph rather than clicking them one by one? What is the maximum battery life, and can we change battery in situ in explosive environments? First question, you can take all the readings from the home screen, that current reading, but in order to take all the readings from each sensor, you have to go into each individual sensor. I've had that question asked quite a bit. So we're actually looking into making a software export that can actually accommodate that. So that is one of the things we're looking at doing, because we get that question quite a bit. What is the maximum battery life? And for the sensors, for the micro PIMs, they're 10 years on one reading per day. For smart PIMs, they're about 5 years on one reading per day. And then on the other wired ones, there's no battery, so battery's not an issue. Can we change battery in situ? No, you need to have in a lot of cases, a hot work permit to do it, because when you unscrew the cap of either a smart PIM or a micro PIM, you're technically no longer in a safe zone. So a lot of cases you do need to have a hot work permit if they are in hazardous rated environments. What will be the approximate cost of 6 sensors? We can open that up after this is done, where we can talk a little bit more, but I'd like to know kind of which sensors we're talking about, whether it's micro PIMs or smart PIMs or something different. So happy to answer that in just a minute. Can these be installed at locations where the pipe has a dent external to monitor? I think I answered that one already. What are the temperature limitations? And is there any device installed for temperature compensation? I think I answered that one as well. So on each one of these items, there's two sensors, two temperature sensors. One's on the top that tells you what the temperature inside the housing is, and the other one is at the bottom. So you actually have two different temperature devices there. Temperature limitations, as I mentioned on the dual, was from -40 F or C up to 150 C. And then depending on if you want to make them permanent or temporary, you can make some changes that way. And then on the high temp sensors, they'll go from -40 up to 500 C. And they're permanent or temporary regardless. And then the last question, as per thickness measurement standard methods, we'll need to calibrate the equipment. I was waiting to get this question. At the same temperature, how does your system compensate temperature effect on measured thickness? How can we comply with confidentiality of the measured results while the data are being stored on the cloud platform? So I think I answered that second one. But the question on thickness measurements, what you're going to want to do is obviously take a handheld thickness gauge out with you whenever you go and do this to take baseline readings. Mark those spots and then put the sensor on that area as close as you can to it. Before you do that, obviously you want to calibrate your thickness gauge. You can also calibrate these sensors if you're going to be going, into a very small zone or, into a very thick zone. You want to obviously calibrate the sensor with the same material standard block, if you can, at the same temperatures to get yourself a good baseline, so that when you put your sensors on, you're getting a good reading. So that's how I would probably answer that one. What is my full name, Strachan, so that I can add you on LinkedIn? You're a good presenter. Thank you. My first name is Steve. My last name is Strachan on the screen. If you go to Sensor Networks on our LinkedIn, you can get there, or it's just my last Strachan at sensornetworksinc.com. And that's everything. So we ran a little bit over, but yeah, really, really good questions by everybody. Nestor, if you want to unmute it for the folks that are left, I'm here, to answer questions and talk for as long as folks would like. And I really appreciate it.
You can unmute everyone because you are the host at the moment.
Yep. So I just unmuted everybody. So you can unmute yourselves if you like.
Well, you're welcome to unmute, and we would like to thank all of you for your time and consideration again, and for the tough question that you put to us. Really appreciate your input to this webinar, and thank you for your time and consideration. If you got any further question that you wanted to ask now directly to us, unmute yourself and please feel free to go ahead.
Yep. Nestor, actually, maybe to answer the question that we mentioned before, ballpark pricing of micro PIMs, we're targeting so the list price on the sensors is $3,500 a piece for the micro PIMs, and that's with a magnet or a clamp. So that's for, each sensor is $3,500. For smart PIMs, it kind of varies based on which transmitter you want, what length cable, which sensor, things like that. But if you do want a budgetary proposal, I would recommend you reach out to Nestor, and we'll be able to certainly get you some budgetary pricing. I know it's that time of the year where a lot of people are working on next year's budget, so happy to give you some budgetary info or talk through, a deployment, what it might look like.
Yeah, feel free to contact us, and I will be delighted to quote you any of those equipment. Okay. If any of you wants to now unmute and raise any question that you might feel that is still pending or hasn't been answered, please do so. If no, we're gonna close this soon.
Yeah.
Well, it looks like everyone is happy. Again, thank you to all of you for your time and consideration. I look forward to address any inquiry or any other detail that we might have missed and you think afterwards. Happy to help you with that. So thanks again for your time, and we're gonna be also editing this recording and send it to all of you.
Yeah, Nestor, check. I don't know if you. I tried to unmute everybody. It looks like everybody's muted. I don't know if that's on purpose or not, but
Hasn't been on mute?
yeah, I think they're unmuted. So.
Okay, yeah, David here. Thanks very much, Steve, and thanks, Nestor. Yeah, very interesting. I've got 2 applications in mind, so I'll talk to the clients and then come back to you, Nestor.
Okay. Thank David for your time and for your consideration, also for forwarding the invitation to your college. Looking forward to work with you.
Yeah, it's a pleasure. Thank you for joining, David. It was nice meeting you.
Thanks, Nestor and Steve, for your excellent presentation. And I will touch base with Nestor with regarding different requirements. So I am from Santos, Australia.
Yeah, Chris is an old friend, has working with me. We were working to the installation of the case study that I put on to the presentation. So he's familiar with the smart pins and looking forward for the micro pins.
And also we check, double check your readings with the phase array, and there is no difference.
Okay. Well, anyone for any more? Well, thanks, Steve, for your support, Mike, and we're gonna close the session now.
Okay, it's past my bedtime, so.
Yeah. Thanks for that. I owe you a beer.
Yeah, no problem. No problem. That was a pleasure. If you guys need something, give me a shout. Nestor, thanks for putting this together, and have a good rest of the day, everybody.
Okay, thank you.
Thanks, guys.